Hey everyone, today we will be investigating the topic of the Boltzmann distribution in the context of chemistry. Firstly, the Boltzmann distribution tells us that the relative population of the number of particles in the upper states decreases exponentially from those in the lower states. Thus, to determine the ratio of particles in the upper energy state to those in the lower energy states, we apply the following formula. So N2 over N1 is equal to exponential brackets the change in the energy divided by Boltzmann constant, which has a value of 1.381 times 10 to the negative 23 joules per Kelvin, and multiply that by the temperature in Kelvin. Note N1 is the lower energy state and N2 is the upper energy state. And it is important to also note the variables in the brackets after the exponential, so this right here, are as a power on the exponential. Let's now put what we have learned into practice. So the example we have is to determine the ratio of particles in the upper energy state to those in the lower energy states, given a temperature of 25 degrees Celsius and a frequency of 559.7 centimeters. First, assume the Boltzmann constant has a value of 1.381 times 10 to the negative 23 joules per Kelvin, and Planck's constant has a value of 6.626 times 10 to the negative 34 joules seconds. To complete this example, we apply the following working out as shown right here. So, we first of all write our Boltzmann distribution formula. We convert our temperature into kelvins, which gives us 298 kelvins. Then we write down our Boltzmann constant. Then we write down a frequency of 559.7 centimeters inverse. Let's convert this to hertz. To convert it to hertz, we multiply that by the speed of light in centimeters per second, giving us 1.6791 times 10 to the power of 13 hertz. Also just note down Planck's constant right here as h. We now apply E equals the product of Planck's constant times frequency, and therefore substituting our Planck's constant right here and our frequency right here, our change in energy is given as 1.126 times 10 to the negative 20 joules. Now we substitute all this data into the Boltzmann distribution formula. After subbing it in, we get a ratio of 0.067 between N2 to N1. Note there is no units here, as this is a ratio, which is the final answer. I hope this video was useful in exposing you to the Boltzmann distribution. Thanks for watching. See you later.